We are starting now with our next session. The session will be managed, it's flexible units again, so quite a bit about that, and the grid service operation. The session will be managed by Professor Nikos Hatziagiou. I'm very sorry again about my spelling of your family name, but it's somehow like that. So I give a hand over to you, and you already have your first speakers here. Thank you.
Thank you very much, Christopher. Good morning. This session is about flexible units and grid service operation. It's quite focused on weather and forecasting. And the first presentation will be given by Johan Nihleen and Alexander Nordling from Vitek, Sweden.
Thank you very much. So first of all, we're very happy to be here, and thank you for the invitation. As already said here, we will move up a little bit in the layers and talk about forecasting now, not the flexibility and virtual power plants and other things. We will talk about 5 steps that we, during our time for making forecasts for companies, have found are things that will optimize, in the end, the quality of the forecast, which is, of course, the whole purpose of our existence. To introduce ourselves a little bit closer, my name is Johan. I'm the head of market growth and also UX design at Vitek. So I'm the primary contact for companies that are not using our products. And then we have Alexander.
Yeah, hi everybody, my name is Alexander Nordling. I work with both existing customers, so helping them with different support areas, optimizing their forecasts and such. As well as setting up new customers, so integrating our forecast into other systems and doing the integration part between systems and setting up new series and setting their models up for the first time and helping them in those initial steps. So basically the best friend of our customers. Before we get into the nitty-gritty details of forecasting, just a few slides about the company that we work for. And we will actually talk mostly about the software group, which is the parent company of us. We were founded in '85. We are a university spin-off. These are the 2 scientists that started off Vitek. And Aiolos, that is our product for forecasting, was the second product we developed within this group. So Aiolos has been on the market for a very long time, a little bit different names, a different shapes, forms, but still the same thing. And our whole business idea is that we develop and deliver very standardized software for very specific needs. So me and Alexander, we work only with TSOs, traders, renewable producers, but we have colleagues that works only in the banking sector, only in different pension funds, etc., real estate agency, hospitals, you name it. So we are all over the society, you could say, but what we do, me and Alexander, is only energy. And what is it exactly that we do at the company? We try to explain it in 4 different squares here. If we start with the red one, which is the most common one for us, is that retail demand forecasting, meaning that we do forecast for the BRP, or as some call it, the ARPs. And we can do that from a very short perspective up to several years, if you like. And then we have the kind of golden square, which is the wholesale part of things, or the TSO forecasting. That is something that we do mostly for the TSOs and also for commodity traders that would like to get an overview of different markets in order for cross-border trading, etc. The blue one, renewables, we do forecasting, or our customers do forecasting for wind power, solar and hydro. And when we talk about hydro, we mean run-of-river. And we do that from 50 minutes up to 10 days. And then we have the white square, which is something that we have been developing quite heavily for the past few years, which is openness when it comes to forecasting. We believe that you should use a lot of data and you should use many suppliers. Which suppliers that you should use is another question, and that's basically what we will talk about today. These are some of the clients. We actually have 2 clients in the room today. They can name themselves in the Q&A after this session if they like. We have TSOs. We have 7 of them in Europe. We have about 60 more that are traders and renewable companies.
So, as I said before, we have 5 simple steps that we see and our customers see improve their forecast quality on an everyday basis. And the first one, the essential one, is creation of quality input data. And we have this kind of schematic view of a everyday process when it comes to making a forecast. And on the left-hand side, we see a box, and that is kind of filtering or reviewing the input data into the forecasting module. One part is, of course, the weather forecast, to make sure that we receive that data and that it's of good quality. And then we have the consumption or production data from wind power plants, from customers, industries, etc. And the problem for our customer was really that they handled huge data sets. They could make forecasts for one forecast series, meaning, for example, one country, up to 100,000 forecast series. So it's impossible for a man to graph that data and to find problems. And they have everyday obligations. It could be intraday as well. And of course, quite simple things like new staff members that need training and need a little bit extra hand in the beginning in order to make good forecasts. So an example here that we can see here is missing data, a quite common thing, or it could also be spiking data. And these are some of the things that you absolutely should have a look into, and we think that this should be an automated process so that you filter out this data. And there are many, many different things when it comes to forecasting for us or for other parties. So gap spikes, manual changes of the data or for the models. There are many different processes. It could be import protocols, it's the export that has been made, etc. It could be different tuning processes of the models and settings in the software that you use. And in the end, of course, the accuracy and reporting of that on different levels. It could that you have different aggregation levels, or it could be that you like to have an executive summary of the quality and really focus on the right things.
Yeah, and the next step is about the weighting of forecasts, and here we're really talking about that we're here in the next step of this everyday process, so when making the forecast. And now we're not going to get into the details in the models per se, but rather talking about the openness of a system to have multiple input, which we have seen has increased forecast quality for our customers. First part of this is, of course, looking at the meteo data, which these are the suppliers that we have in our package and that we are using, that then goes into as input when making one energy forecast. But if somebody has any others, then we always as well are open to take that data in as well. And this we take in so that when we're making one energy forecast, we're actually making, say, 5 energy forecasts. So we are making one energy forecast only based on, say, weather from Meteor Group. Then we're making one energy forecast that's only based on weather from the Deutsche Wetterdienst, and so on and so forth. And we do this because then we can weight these together, but also for evaluation purposes, so that we then can go back in time and ask and answer different what-if scenarios. What if we would have used this provider instead of this provider? What would have been my results then? And then take that information and then go forward to then improve your forecast as well, so that you can answer those what-if questions and so that you can then optimize and improve your forecast with that information. When we weight these together, we weight them. We never normalize, or you can push the weighting to be normalized and positive, but you don't have to. You can set it to be over 100%, so that if you have a bias, you can post-process this as well in the system, so that if you have a bias of 2 degrees or anything, then you can take care of this afterwards, so that you then can up your forecast accordingly, so that you get rid of that bias with a post-processing procedure. And we also divide it up into different time horizons, so that you can then depending on if it's night or day, you can have different angles if you heighten or lower the forecast depending on what time of day it is. Especially for demand, we see that this is a good thing to divide it up into finer details so that we can take caution depending on which part of the day it is and which part of the profile we want to change. These weightings, as Johan said, we want to be open, so we really want that you have the possibility to set them accordingly, so you have the information of how each of these ones are performing, so you can set them to be 20% each, or you can set them to be 70% from one or the other, or you can then also let the system choose this for you so that you have the possibility to get that optimized and that calculated weights of these ones. This is just the weather, but we also see that taking it to the next step, so not just having multiple weather inputs to take care of different scenarios, but also to have multiple models so that you can then get really the benefits of different models and different ways of doing forecasts, so that you can, depending on the situation and the actual measurements or the actuals of the day, you can look at different models and how they behave and see that spread, and then you can take and weight these together to get the best forecast. And the next part, of course, is to validate your forecast. So to look at the forecast that you're making and see that is it okay. There are different ways of doing this. So one way of doing this is to continuously do this evaluation so that you can display your historical forecast with your historical measurements to see if you have any errors, and then you can learn from that when you're validating your forecast to see is it in the right place, and then you can display different time horizons here as well. So you can have the intraday, you can have the day ahead, and then you can also see your positioning depending on what time of day it is, like according to if it's day ahead and intraday, so to see what's the difference between the two. And you can also see the different changes that has been made to a particular historical forecast. So if your colleagues make any changes, then you can take these changes and learn from them and apply them to the future as well. Then there are other parts of validation as well. So looking at comparing your forecast to historical measurements, as well as to the different input data from weather and the different inputs from alternative models. See how are they reacting, and plotting these on top of each other. And the good thing here is to, even if you're making really a bottom-up approach where you're forecasting thousands and thousands of forecasting series, you can still make this validation on an aggregated level, which means that you can spot these differences quite easily, and then you can take the necessary precautions to actually better your forecast if you see that there's something wrong. So first, the historical forecast. Here the idea is to display just measurements against your forecast to see that your profile and your level is right, so that you then compare it to similar conditions that you have the same day and the most previous days and so on, so that you can see and see that it looks proper. You can also display the percentiles so that you can see what error margins do you have been before, and then are we in the upper level and the lower level, and should we, due to this, maybe correct our forecast as well to see in what range we are. We have different models input. So here again, you have different models that react in different way. You can have a very short reactive model, which could be good for when you have changes in the system due to customer change, due to spikes in weather, and then it's good to see at these models to see how they behave compared to maybe a broader model that takes in more data, that is more stable but not as reactive and fast responding. And then you can have these multiple inputs as something to look at. Third, of course, is to look at this these weather inputs, and here, of course, mostly looking for outliers. So if you have five input weather parameters and one is missing, and that carries, say, 50% weight, that will affect your forecast quite heavily. And you can see if you have one outlier and that carries a lot of weight, and you have four other forecasts that are quite similar, then maybe I would rather believe in the four that are quite similar than the outlier one. And this is a fast way of just getting that validation that everything looks okay, rather than nitty-gritty trying to optimize according to the forecast. And you can also simulate temperature to see an uncertainty here as well, so to see if we have increase or decrease by plus minus 1 degrees, how will that affect my actual energy forecast, to see how volatile is it according to the temperature change that we could be seeing for tomorrow or for the next hours. And then the last part as well is to not just by doing these kinds of validations yourself, but actually letting the system validate for you as well. So if you have real-time data, you could make changes accordingly. So you can make changes linearly, autoregressively, by exponential smoothing to match the corresponding level and to match the upcoming intraday forecast. And also you could learn from your previously made forecast and train your model on the most previous day, as you see in this example where we have an inertia that we have quite high on the night, so we have actually lowered it a little bit, and then we have a hourly dysfunction there, and from this you could actually train the model to forecast the errors, and then you can apply those errors to the forecast to adjust the current forecast as well. So you're moving with that. So letting the system do the validations for you, basically.
And number 4, use automation in the ways that you can in order to save time and spend your valuable time on the different things that make a difference. This could be the whole process of making a forecast, or it could be a semi-version of it where you automate different things. It could be, of course, the import of data. That's not something that you should spend time on as a regular user. Filtering that I mentioned before, the quality of the data. Tuning models and settings is also something that should be done automated, even though you should have full insight of how it's done. Preset forecast horizon, what we mean with that is that you already have an automatic forecast when you go in every day and would like to validate it in the different ways that Alexander just explained. It could be trigger-based actions, it could be reporting, and it could be in the end that you could reach a more complex modeling setting or approach with the help from different automations in the total process here. And the whole idea in the end is to avoid human error.
Yeah, and then the last part, which is a continuous work and something we see that is very important to proper evaluate your data sources. You have a lot of input, so an important part of this is, of course, to look at all these inputs that you have and see that which of them are actually performing and which are not performing. When you're doing this, since it's something that you do in a combination, you want to weigh them together, so you can evaluate them separately to see one by one how is a weather provider doing, how is a forecast supplier doing, but it's also always good to think about the portfolio, think about the combined solution of these. How much weight does this carry on into my final forecast, and does it help my final forecast if I use it in collaboration with other models? And here you can think just in terms of forecast error, in terms of energy, but you could also look here at the actual cost. If you have one provider that is performing well, but it's very, very costly, then how well can I do if I rather than combine, say, 2 or 3 cheaper options? Could I then achieve the same errors, and basically could I then achieve a more cost-effective way of doing this?
Just an add-on to the last point here, that we see when our clients try out more than one model approach or one supplier for forecast, it's always the case that the combination of maybe 3 of them is better than the best of the suppliers. So we really recommend you to properly evaluate different sources. It could be everything from the input of weather data to different models. So to sum things up, creation of quality input data, filter your data in whatever ways that you can. You should have an automated process for that. Weight different forecasts together, as we just mentioned, that is the key. Make manual validations. The customers that we have that put in a little bit of time every day trying to make different scenarios, look at p-values, etc., they are making better forecasts. Use automation to save time, and in the end, start off in the right corner, take the right data from the beginning, evaluate what you need, and then use it.
You could say that automation is a key as well, because the good point with having a system rather than having an Excel is that you have a standardized way of doing things, and you have the enabler to handle much larger data sets rather than just doing it on top aggregated level. You can still do the same different kinds of validations on the top aggregated levels, but you have the possibility here to deal with larger and larger data sets, and that we see as a good enabler for forecast quality as well.
Thank you very much.
Let's thank the speakers. It's a nice paper. So, any questions? Yes, please.
So maybe you can move to the slide over.
Just wait a bit for the mic.
And show us again the optimal weighted energy forecast slide. This is also the way not only to weight different providers or different models, but also to weight range of ensembles or at least clusters of possible solutions. This is something that is really needed because weather forecast is not deterministic one curve. It's range of possible solutions, and it's much easier for a end user to see the range of possible consumption forecast, wind forecast, hydro generation forecast, and to see what is the range where he can move when he makes some kind of bids and alternative choices.
Yeah.
And what is really good regarding this tool is that it's really open. It's not a black box. You can really see every tiny single detail, what is the input data and what is the output data. It is really useful.
So I think that's perhaps a very interesting idea of your presentation, that you use several suppliers and you weight the results. And I was wondering, each model should be perhaps more adequate for a certain case, no? So I wonder if by your experience you have found some of the stuff better than others, and you more and more use more, let's say, exact models than all of them.
Yeah, definitely. You have different types of timelines and different types of customers you want to forecast. So say you have a typical household, then you have a more typical profile-based and temperature-dependent. But then if you have an industry, then you have another set of forecasting. And we have specific models for specific needs, but still we have this approach that it's not only about changing the model type, so it's changing the algorithms, but it's also about changing the data sets that you train the model on, which means that you can have a reactive model and a more stable model, which means that you can move or not move according to a certain types of situation. And then you have these two different possibilities, which gives you the possibility to choose the right one as well.
Is there any more questions?
Yes, thank you for your presentation. First, a remark, among the meteorological provider, I don't see Météo France. Is it any reason on this? And because there is free data, you could have it for free. And also, I see that Météo Consult or other intermediate supplier are among also Met Office. Météo Consult doesn't have its own model. So do you use only raw data, raw model data like the model of Met Office, also pre-processed data?
Yeah, it's different between the different providers. The reason why Météo France isn't there is because we started out in the Nordics. That's why the beginning of the package is quite Nordic based. But when moving towards Central and South Europe, we also want to get more of data from there. So the first one we took in was the Deutsche Wetterdienst, but Meteofrance is of course a good option as well. What data we use then varies between that what we get from them, like from Foreca, we get their own model and their own post-processed forecast together with the raw data from EC as well. And some of these we have also an open API against, so that's what's available for some of them.
But that's something that our modeling department works with every day, I would say, trying to find new data sources, talking to different institutes, and also the modeling approach, of course, so that we could get a good example, an ensemble for